Okay, so alternating current and voltage can be represented. Alternating current and voltage can be represented graphically as a sinusoidal wave. Okay, they have the same properties as any other wave that you've dealt with in standard grade. They have amplitude, they have frequency, they have wavelength, they have peaks and troughs. They have all the different parts that you should know about. Okay, so the types of things they would have is they have lambda for wavelength. They have frequency for the number of waves in a second. They have period for the time of one wave. All these properties are the properties of a wave. Okay, they have amplitude as well. We'll just say amplitude as A. So they have all these things. And this wave on the left here is going to have the same properties. The main points we're interested in, okay, the main things we want to look at is probably the amplitude. The amplitude is from here to here. That would be A, and A equals amplitude. And also you want to know that this is the peak of the wave. This would also be a peak of the wave here. And this one about the bottom would be a trough. Now we obviously are interested in the time it takes as well. So we want to know that this also is a wavelength lambda. And the time for that wavelength is the period. So if this was t for time, then this point here would be period, large T. Okay? Now I'd like to use large T. Sometimes in the data books it says P for period. Really large T, because large T is not used for anything else, whereas large P is used for power. And we're about to do electricity and electronics and use power quite a lot, so we don't really want to use P for period. So you've got a trough at the bottom, peak at the top, amplitude here, the wavelength, the large T here is your period, and obviously you get another peak as well. The most important things about this wave is you want to be able to work out from looking at a oscilloscope, from looking at this wave, okay, what actual voltage am I getting here? If this was a wave coming out the mains, what actually am I getting? Right? So if you look at the wave itself, you could get a number of things from it. The main thing you're going to get from it is the peak value. You can look at the wave and say, what is my peak value? So we know V peak. So this would be voltage. So this would be voltage up this side. And you'd have V peak. So V peak would be this value here. That also equals Vp. Now, it's not that value all the time. It varies quite a lot. It's a constantly changing signal. So we need to think about what an average value is of this. So what we have is we develop another value, which is RMS value, the average value. So we have VRMS, which equals kind of like, I mean it's not exactly, but it's pretty much the average value you're going to get from a sinusoidal wave. So it's like an average value, which equals V, and it's root mean square, not anything else. Although you probably will remember it as something else. Okay? It's root mean square. The root mean square value. Now the root mean square value is the kind of average, and to link these two together, there's a formula which you're given in the exam, is VRMS equals V peak over root 2. Now, given V peak, you can know VRMS. Given VRMS, you can get V peak. Now you might say to yourself, right, what difference does it make? It's still a voltage. We can still use voltage. Well, when you're doing any calculations for power, current, resistance, any of these things, or if you want to know your standard power, right, you need to use the RMS value. So the RMS value is the one you use for all your formulas. So that's like saying your average value, your average voltage. It's not the peak value, the one that hits every so many times a second. It's the average value. So that's VRMS. And you're often asked to convert between the two of them. Okay? So, state relationship between peak and RMS values for a sinusoidal varying voltage and current. That is the relationship between the two of them. Alright? So, once you've all got that? Yep. So, just write down a note then. When doing any calculations, unless asked for, unless asked for peak, always convert and use the RMS value. Now, I said this is alternating voltage and alternating current. So, if I grab a data book, you'll find in your data book you're not just given the formula for voltage, you're also given the formula for current as well. There's two of them, because I mean it is an alternating current as well. If you were just to measure current out the plug, it would be a sinusoidal wave as well. So, there we go. The one you're actually given in the exam is this one, which is again slightly different, but it says the same thing. V peak equals √2 VRMS. It's just rearranging the formula. But because it's a varying current and varying voltage, you can also write down the same thing for current. I peak equals √2 IRMS. It's the same thing. That graph that we drew on the previous page could have been for current, or it could have been for voltage. It doesn't make any difference. It's just because that would have looked sinusoidal. Okay? And RMS in both values, in both formula, mean the root mean squared. And these formulas are given to you in the exam. Okay? So, what I'll do is, we're going to, later on, we'll give you some questions on using these. It's really quite straightforward. It's just whether or not can you put √2 into the calculator. It's not the root of 2 times VRMS, it's the root of 2 times VRMS. Okay, just make sure we don't get that error. I don't know whether or not I should put, I don't know if that helps, you put the wee √2 sign down like that, just to let you know it's √2. So that's VRMS, David, shush. That's VRMS and IRMS. Now what we also need to do, and we're going to practice that just now, is we need to be able to look at an oscilloscope screen and measure the frequency. Now this takes us back to this diagram here. If we want to know the frequency of this wave here, then we can't work it out from just looking at it, right? We can't just work it out from looking at that there. We need to have a number. We need to be given a number. We need to be given a number for time. Okay? So if we want to calculate frequency, so the next thing we're going to do is calculating frequency from a screen. Okay? So calculating frequency from an oscilloscope. Okay, so we need to be able to calculate frequency from this oscilloscope. You'll often be given the exam an oscilloscope screen, or a CRO, a cathode ray oscilloscope. Now, whether or not I can spell oscilloscope is another thing. What's that?
You can't say it. You said it 3 times, 3 different ways.
What?
You said oscilloscope.
And I'm really joking, it's not a oscilloscope.
Yeah, I know, but then you said oscilloscope, oscilloscope.
Oscilloscope. Yeah, it's there. Calculating frequency from an oscilloscope. Okay, calculating frequency from an oscilloscope. So, very briefly, you draw a box to signify what the oscilloscope is, and draw a wave in it, doesn't matter what the wave looks like. And then down the sides, you can just draw little segments and along the bottom. Now, these segments correspond to the segments on the oscilloscope. I'm not going to bother doing all the lines back and forward. You can see it on the oscilloscope itself. And these obviously will be connected top and bottom, and you get a kind of grid on it. Right? Now, every oscilloscope will have a grid on it. Now, the oscilloscope's only going to tell you 2 things. It's going to tell you the value of these segments, and it's going to tell you the value of these segments here. Okay? The ones on the left are the V volts per division, and the ones on the bottom is the time base, which essentially is the number of seconds per division. So, 2 pieces of information, and you're normally given a dial. In the exam you're given the dial, which is rather bizarre, and on the dial you'll have little segments on the dial, and you'll have the dial pointing to a certain number, and you have this number on the side. So you might be told that this is the volts per division, and this is the time base. And you'll be given a number around the SI, so you'll be given 0.5, 1, 1.5, 2, 2.5, and then time base should be given as sort of 0.1, 0.2, 0.3, 0.4, 0.5. You need to be able to read the dials, get what the time base is and the volts per division, and then from that you can work out your peak values and your frequency. So I'll give you a second to copy that down, and then we'll talk about how we're going to use this information. Using this information, we have, so let's say, there's a few things we want to calculate. If we want to know the peak value of the voltage, if we know peak voltage, then we can work out RMS. And if we have RMS, we can work out our formulas. So to get V peak, so Vp equals our amplitude. To get that, we count the number of divisions from the centre point up the way. So all the graphs need to be centred down a centre line. We count the number of divisions from the centre line to the top, and that's our, and you multiply that by the volts per division, you get your amplitude. So Vp equals amplitude equals volts per division multiplied by the number of divisions from the centre to the top, multiplied by our divisions. And that's from the centre to the top. And that's how we get amplitude. That makes sense? So for the centre, the number of divisions it takes to get to the top of the wave is our V peak. We can then get VRMS from that using the formula. The other thing we can get from this is the period. The period equals the length of time for one complete wave. So we look for one complete wave and we count the number of divisions along the way on the time base it is for one complete wave. So that is time base times the divisions along the bottom for one wave. Divisions for lambda, one wave. And this is the bit you should be able to do. You should be able to do the top one from standard grade, VP. The time base, again, this is a wee bit new to you, but we're not asked for period very often. The more important part of it is the frequency. Frequency equals 1 over period. So if you're ever asked to work out the period or the frequency of a wave, you work out the period, and then you do 1 over frequency, 1 over period to get your frequency. Okay? Right. So, we'll give that a go. We've got our oscilloscopes there. We're going to get ourselves into 4 groups. Use your doofers to answer, and I'll give you different frequencies and you'll have to try and calculate it. I'll give you a little tutorial on how to use these oscilloscopes. But essentially, this information on the board will allow you to answer a question on it. But then in terms of just a little bit more broader knowledge, we'll do the oscilloscopes you've got in front.